Hello everyone, the Teen Engineer here. So in this video we're going to be solving this physics problem which involves linear momentum and basically that linear momentum energy problems. So a 600-gram ball of putty moving horizontally at 7 meters per second collides with and sticks to a block lying on a frictionless horizontal surface. If 30% of the kinetic energy is lost, what is the mass of the block? So when we deal with linear momentum problems, first we have to determine if it's an elastic or an inelastic collision. In this case, it's inelastic and completely inelastic since they stick together after the collision. So let's just draw how it should look like before. This is before collision. You have like this. There's like a ball going this way, 7 meters per second. And then you have the block here. And then after that, they stick together. So after here, they are stuck together as one and they're moving and there's no friction. And 30% of the kinetic energy is lost. So what is the mass of the block? So first off, let's determine the kinetic energy before the collision. So initial kinetic energy, Ki, is equal to 1/2 mv squared is equal to 1/2, and then mass, let's convert that to SI units. So 600 grams is equal to 0.6 kilos. 0.6 kilos times v squared, so 7 meters per second squared. That's equal to, let's just do that real quick. That's 1/2 times 0.6 times 7 squared, 14.7 joules. So 14.7 joules. So that's the kinetic energy before. And since 30% of that kinetic energy was lost, then the kinetic energy after, so kinetic energy after, is equal to 0.7 of the kinetic energy initial, because 0.3 of it was lost. 0.3 out of 1, so that's 30%. So that would be equal to 0.7 times 14.7. So that will be 10.29 joules. So the final kinetic energy will be 10.29 joules. Now, to find the mass of a block, we have to use linear momentum. So let me just do this. And so we can do Pi is equal to Pf, or initial momentum is equal to final momentum. That's always true, whether it's an elastic or an inelastic collision, that's always true. So yeah. So the initial momentum, it's mass times velocity, and then that will be equal to total mass times velocity, right? So we have the initial mass and we have the velocity, so that will be 0.6 kilos times 7 meters per second is equal to total mass times final velocity. I'm just going to change that to a vector, and that's initial. Now, the thing I wrote here is total mass, because it's not the same as the initial mass, because they're stuck together as one body. So we have to take into account the mass of the ball and the mass of the block. So it's their mass is combined. So 0.6 times 7. 6 times 7, that would be 4.2. This is initial. The initial momentum will be 4.2 kilogram meters per second, and that will be equal to mc vf. Okay, now since we have two variables here, we can't really solve this, but we also have another equation. Using the kinetic energy. We also have another equation with those two variables, which allows for a system of equations that we can solve. So this is the first equation. I'm just going to name that one. And then the second one is K final is equal to 10.29 joules. And the equation for kinetic energy is 1/2 mv squared. V, so that would be V, and this would be T, and that would be squared. Good. So now that we have those two equations, I'm going to isolate mass in this equation. Doesn't really matter which one. So let's do times 2. So 10.29 times 2, 20.58, 58 joules is equal to total mass times Vf squared. And then to isolate mt, we have to divide by Vf squared. So that would be 20.58 joules divided by Vf squared is equal to total mass. Now we can plug this back into the first equation. So this would be 4.2 kilogram meters per second. It will be equal to 20.58 joules over Vf squared times Vf. So if Vf cancels out, this one and this one, and then that will leave us with 4.2 kilogram meters per second is equal to 20.58 over Vf, and then that means that 4.2 Vf is equal to 20.58, and then Vf is equal to 20.58 over 4.2. So to do that, it's equal to 4.2. It will be equal to 4.9. meters per second. So if you were trying to find the speed after the collision, it would be 4.9. If you were trying to find the mass, then all you have to do is plug it back. So that's the speed after collision. Because some problems also demand you to find the speed. And if you want to find the mass, then you can just plug it back in here in 1 or 2 in the first equation, but I'm just going to plug it back into the first equation. So 4.2 is going to be equal to mt times 4.9. And so we just have to divide by 4.9. So 4.2 divided by 4.9, it will equal to 0.86 kilograms, which is 860 grams. Now that's not the final answer because this is the total mass. So that's the mass of the putty and the ball. And since the ball and the block, and since we already know the weight of the ball, then we can just subtract it. So mt is equal to, mass of the ball plus mass of the blocks, and then that's equal to 860 grams is equal to 600 grams plus mb. So mb is equal to 260 grams. So that's the final answer. Thank you. If you like this video, then subscribe, watch more videos, because I'm going to have post up more problems like these. So this was a problem with linear momentum and a bit of energy, and yeah.